Revision of algebraic expression. Variable. As the name suggests, something that keeps changing. Variable can take up different values. It is denoted by the letters of English alphabets. For example, X, Y, L, M, and so on. Constant, its value is fixed. For example, 72, 59, and so on. Algebraic expressions. It is formed with the help of constants, variables, and arithmetic operators. For example, 4xy plus 9. So here the variables used are x and y, and arithmetic operators used here are multiplication and addition, constants 9 and 4. Terms. Terms are added to form an algebraic expressions. Here the terms are 4xy and 9. Terms are added to form an algebraic expression. So for this algebraic expression, terms are 4xy and 9. Terms, it is formed by the help of the product of its factors. So what are the factors for this term? It is 4, x and y. When you multiply these factors, you get the term 4xy. Coefficient, or simply the numerical coefficient. It is the numerical factor of the term. For example, if I ask you what is the coefficient of this term, it is 4. It's the numerical factor of the term. Sometimes it can be any one factor of the term for the remaining part of the term. For example, here if I ask you what is the coefficient of y, so you have to just hide y, remaining is the coefficient, so that is 4x. So here for this question, if I ask you what is the coefficient of this term, it is 4. Get the algebraic expression in the following cases using variables, constants, and arithmetic operations. So the first question is 1/4 of the product of the numbers P and Q. So 1/4 of product of the numbers P and Q. Product of the numbers of P and Q means P into Q. So if you simplify this, of means multiplication. So it is PQ by 4. Next one, sum of the numbers A and B subtracted from their product. So sum of the numbers means A plus B. Product of the numbers means A into B. So sum of the numbers A plus B subtracted from their product, that is AB. AB minus A plus B. Numbers x and y both squared and added. So square of x and y is x square and y square. So numbers x and y both squared and added. So you have to add after taking the square. Identify the terms and factors in the expressions given below. So these are the two expressions given. You have to identify the terms. So you know that terms are added to form an expression. So this is one term, this is the another term. They are added to form this expression. So the terms here are 3 by 4x and 1 by 4. So what are the factors for this? 3 by 4, if you multiply with x, you get 3 by 4x. Here it is 1 by 4. For this one, terms are added to form an expression. Here it is minus sign. So I can rewrite this as 5y plus of minus 4x. So now you can see plus into minus is minus. Terms are added to form the expression. So what are the terms here? 5y and minus 4x. So it is 5y and minus 4x. So what are the factors for this term? So factors are 5 and y. So when you multiply 5 and y, you get the term 5y. When you multiply minus 4 and x, you get minus 4x. So the term here is minus 4x and the factors for minus 4x are minus 4 and x. Show the terms and factors by tree diagram. So you have to show the terms and factors with the help of tree diagram. So let us see how to make a tree diagram. So here the expression given to you is 1 plus x minus y square. So first let us write down the expression 1 plus x minus y square. So next you have to write down the terms. Terms are shown with the continuous lines. So there are three terms here. 1, x and minus y square. Because you can write this as plus of minus y square. So terms are added to form an expression. So 1 plus x plus of minus y square. So what is the term here? Minus y square. Now factors of minus y square are minus 1, y and y. So when you multiply minus 1 into y, you get minus y square. So factors are shown with the help of dotted lines to avoid the mixing of terms and factors. Let us take this question, minus ab plus 2b square minus 3a square. This is the expression given to you. You need to find out the terms and factors for this expression with the help of tree diagram. So what, let us first write on the expression here. So it is minus ab plus 2b square minus of 3a square. So you can clearly see there are three terms here. First term is minus ab, second term is 2b square, third term is minus 3a square. So what are the factors of this term? Minus 1, a and b. When you multiply these factors, you get minus ab. What are the factors for this term? 2, b and b. So when you multiply this, you get 2b square. Factors for minus 3a square? Minus 3a and a. So minus 3 into a is minus 3a square. Now let us take this question. Identify the numerical coefficients of terms other than constants in the following expressions. So here, this is the expression given to you. You have to write down the numerical coefficients of the terms other than constant. Means you don't have to consider this. It is minus 3t square. The term considered here is minus 3t square. What is the numerical coefficient here? Minus 3. For this one, there are three terms here. What are the three terms? X, 2xy and 3y. So you have to just write down the numerical coefficient. Numerical coefficients are the numerical factor of the term. So what is the numerical factor here? 1. 1 is not written. Generally 1x we don't write. So 1 is the numerical factor here. So it is 1. Numerical factor here, it is 2. That is called as the coefficient or simply the numerical coefficient. Numerical coefficient or simply the coefficient. Here, numerical factor is 3. So, the coefficient here is 3 or the numerical coefficient here is 3. Now, let us take this question. Identify terms which contain y square and give the coefficient of y square. So here, this is the expression given to you. Which is the term containing y square? This is the term. So that is minus x y square. So you need to find out the coefficient of y square. So you have to just hide y square. What is the coefficient? Minus x. So you know that one more definition, it is told that coefficient is any one factor of the term. So here minus x is the coefficient for y square. Here you have this term and this term containing y square. So let us write down minus 15x y square and this one is 7y square. So what is the coefficient of y square? Minus 15x. Just you need to hide y square. What is the coefficient of y square here? 7. So these are the coefficients of y square. Like and unlike terms. Like terms have same algebraic factors. Unlike terms have different algebraic factors. Let us take this question. State with reasons which of the following pairs of terms are like terms and which are unlike terms. So here the first question is minus 4ab and 7ab. So for minus 4ab, the factors are minus 4a and b. So when you multiply this, you get minus 4ab. Factors for 7ab are 7a and b. So when you multiply 7a and b, you get 7ab. So algebraic factors for this one is a and b. For this one, a and b. So these two terms have got the same algebraic factors. So they are the like terms. So minus 4ab and 7ab are like terms. 6xy square and 9x square y. So what are the factors for 6xy square? Factors are 6, x, y and y. So when you multiply it, you get 6xy square. For 9x square y, factors are 9x, x and y. So algebraic factors for this one, it is x, y and y. For this one, algebraic factors, x, x and y. So for these two terms, you can see the algebraic factors here are x, y, y. Here it is x, x and y. So algebraic factors are different. So they are unlike terms. So 6xy square and 9x square y are unlike terms. Here both have the same variable, but the powers are different. So you can see that they are the unlike terms. Monomial, binomial, trinomial and polynomials. Polynomial having one term is called as monomial. Polynomial having two terms is called as binomial. Polynomial having three terms is called as trinomial. And beyond that, we just say polynomials. Classify into monomials, binomials and trinomials. 4y minus 7z. So it has got two terms, 4y and minus 7z. So it is binomial. This one has got one term, so it is monomial. It has got three terms, x, y and minus xy. So trinomial. This has got one term, so monomial. Addition and subtraction of algebraic expressions. Question, you have to add this algebraic expression and this. So let us write it down. The expressions which you have to add. First one is 3p square q square. Then minus 4pq plus 5. So we are going to write down the like term below the like term. So 7p square q square. We'll write it here. So this is 7p square q square. These two are like terms. Then plus 9pq. So these two are the like terms. This is a constant plus 15. Constant. So you need to add. So plus sign. So you have to just add the coefficients here. 7 plus 3 is 10. P square q square. 9 minus 4 is 5. So 5 pq. 15 plus 5, 20. The answer for this question is 10 p square q square plus 5 pq plus 20. Now here subtract this algebraic expression from this. That means first you have to write down this algebraic expression. That is 5p square plus 3q square minus pq. So from this you have to subtract this. So this one you will write it below. So here it is 5p square and here it is minus 3p square. So let us write down below this. This is minus 3p square. This is 3q square. So here minus 5q square. I'll write down below this. These two are like terms. Minus pq, here plus 4pq. So I'll write down below this. So minus pq and plus 4pq are like terms. So we have arranged the like terms one below the other. Now you have to subtract this from this. So you have to subtract means you have to put a minus sign here. So minus sign here means minus is fully for all the terms. So minus into minus is plus, minus into minus is plus, minus into plus is minus. Now you have to just add the coefficients. So 5 plus 3 is 8. So here it is 8p square plus 3 plus 5 is plus 8 q square minus 1 minus 4. So minus 1 plus of minus 4 is minus 5. So this is minus 5pq. So the answer for this question is 8p square plus 8q square minus of 5pq. From the sum of this expression and this, subtract the sum of this and this expression. So what you have to do? First you need to find out the sum of these three expressions and you have to find out the sum of these two expressions. Then you have to subtract the sum of these two expressions from the sum of these three expressions. So let us write it down. The sum of these three expressions, first expression is 2y square plus 3yz. This is your first expression. Next expression is minus y square minus of yz minus of z square. Third expression which has to be added is yz plus 2z square. So we will group the like terms now. So here it is first 2y square minus y square and that's it plus 3yz, here minus yz, here plus yz. These three are the like terms. Then you have minus z square and here plus 2z square. So here how many terms are there? 1, 2, 3, 4, 5, 6, 7. So here 3 plus 3, 6 and 1, 7. So you have written down all the terms. Now you have to just see the coefficients. So 2 minus 1 is 1. So this is y square. 3 minus 1 plus 1. So you can cancel this. Minus yz plus yz. You can cancel. So only 3yz is left. So plus 3yz. Here minus 1 plus 2. So this is 1. So plus z square. So we have found out the sum of these three expressions. You have to subtract the sum of these two expressions. So first let us add these two. It is 3y square minus z square. This you have to add it to minus y square plus of yz plus z square. So now let us group the like terms. So here you have 3y square. Here you have minus y square minus z square. Here plus z square. Then plus yz. So here you have got 5 terms. Here also you have got 5 terms. So let us now cancel minus z square and plus z square. So here you have got 3 and coefficient here is minus 1. So 3 minus 1 is 2 y square plus yz. So you have to subtract this expression from this expression because the question says from the sum of these three expressions you have to subtract the sum of these two expressions. So from the sum of these three, what is that you got? Y square plus 3yz plus z square. From this expression you have to subtract this, that is 2y square plus yz. So here we will copy this expression as it is. This is y square plus 3yz plus z square. Minus into plus is minus 2y square. Minus into plus is minus yz. So here you have y square and here minus 2y square. So your coefficient is 1 and here it is minus 2. So 1 minus 2 is minus 1. So this is minus y square. You have plus 3yz and minus yz. So your coefficient is 3, here it is minus 1. So 3 minus 1 is 2. So this is 2yz plus z square. So this is the answer for this question. Finding the value of an expression. Simplify the expression given below and find its value when x is equals to 3, a is equals to minus 1 and b is equals to minus 2. So this is the expression given to you. It says simplify. So first you have to simplify this. That means if there are any like terms, you have to add. So let us write down this question. It says 2x plus 2a minus 2b minus 4 minus 5 plus a. So let us group the like terms here. 2x plus 2a and a, they are the like terms. So I am writing as it is. Minus 2b minus 4 and minus 5, they are the like terms. So I am writing together here. So 2x 2a plus a, here coefficient is 2, here coefficient is 1. So 2 plus 1 is 3. So this is 3a minus 2b minus 4 and minus 5. So this is minus 9. So now you need to find the value after simplifying this expression. So we have simplified this expression. We have added the like terms. Now you cannot further simplify because there are no like terms to be added here. So now you have to find the value of this expression when x is equals to 3, a is equals to minus 1 and b is equals to minus 2. So we are going to replace the values of these variables from here. So value of x, it is given to you as 3 plus 3. Value of a is minus 1. So this is minus 1 minus 2. Value of b is minus 2. So into minus 2 minus 9. We are writing like that. So 2 into 3 is 6. Plus 3 minus 1 is minus 3. Minus 2 minus 2 is plus 4. Minus 9. So as per BODMAS rule, first you need to add. So 6 plus 4 is 10. Minus 3 minus 9 is minus 12. So 10 minus 12 is minus 2. So the value of this expression is minus 2. Now let us take this question. What should be the value of a if the value of the expression this equals to 5 when x is equals to 0? So here you need to find out the value of a when this expression is equals to 5 and it is also given that x is equals to 0. So let us write it down. So 2x square plus x minus a equals to 5. So you have to find out the value of a when x is equals to 0. So you just need to replace the value of x here as 0. So I am just replacing the value of x as 0. So this is what you will get. You have to just replace x with 0. Now this is 0 and this is 0. What is left here? Minus a is equals to 5. You need to find out the value of a. How are you going to do it? Multiply minus 1 both the sides. So I am multiplying minus 1 this side and this side as well. So minus into minus is plus. So here you will get a. Plus into minus is minus. 1 into 5 is 5. So the value of a is minus 5. Rules for number patterns. Observe the patterns of digits made from line segments of equal length. You will find such segmented digits on the display of electronic watches or calculators. So here you need to observe the pattern of digits made by the line segments of equal length. So such type of display you will find in electronic watches or calculators. So let us observe now the patterns of the digits for 6. So when there is 1, 6, how many line segments of equal length are needed? 1, 2, 3, 4, 5, 6. 6 line segments of equal length are needed to form 1, 6. How many line segments will be needed to form 2 sixes? So till here it is 6, 7, 8, 9, 10, 11. So when there are 2 sixes, number of line segments of equal length required is 11. When there are 3 sixes, till here it is 11, 12, 13, 14, 15, 16. So this is 16. When there are 4 sixes, then number of line segments required is 21. So if there are n sixes, then the number of line segments required is 5n plus 1. So let us now observe this pattern. Here there is 1, 4. So how many line segments of equal length is needed? 1, 2, 3, 4. 4. Here when there are 2 fours, till here you counted 4, 5, 6, 7. So you need 7 line segments of equal length to form 2 fours. For 3 fours, how many line segments? Till here it is 7, 8, 9, 10. So this is 10. For 4 fours, it is 13. If there are n fours, then the number of line segments needed is 3n plus 1. Let us see this pattern now. So if there is 1, 8, number of line segments of equal length is 7. 1, 2, 3, 4, 5, 6, 7. When there are 2 8s, till here it is 7. 8, 9, 10, 11, 12. So this is 12. When there are 3 8s, till here it is 12, 13, 14, 15, 16, 17. So this is 17. When there are 4 8s, then the number of line segment required is 22. So if there are n 8s, then how many line segments will be needed? 5n plus 2. So here the question asked is, here we have to first discuss this. If the number of digits form is taken to be n. So here the number of digits form taken to be n. N here is the number of digits. So the number of line segments required to form n digit is given by the algebraic expression. So this algebraic expression gives you the number of line segments required to form n digits. So how many segments are required to form 5, 10, 100 digits of the kind 6, 4 and 8? So we are going to use this algebraic expression to find out the answer of this question. So number of digits formed when it is 5. When there are 5 sixes, then how many line segments will be required? The general formula here is 5n plus 1. When there are n sixes, but here the value of n given to you is when there are 5 sixes. So what is the number of line segments required? It is 5. The value of n is number of sixes, which is given to you as 5. So 5 into 5 plus 1. So that is equals to 26. Now when there are 10 sixes, so the value of n is 10. So 5 into 10 plus 1. So 5 into 10 plus 1. So this is 51. When there are 100 sixes, then 5 into 100 plus 1. So this is 5 into 100 plus 1. So this is 501. So now how many line segments will be required when there are 5 fours? So this is the algebraic expression for n fours. So number of line segments required is 3n plus 1. So now the value of n given to you is 5. So when there are 5 fours, how many line segments will be required? 3 into n value is 5, because there are 5 fours plus 1. So this is 16. Now the value of n is given to you as 10. When there are 10 fours, then how many line segments will be required? 3 into 10 plus 1. So that is 3 into 10 plus 1. So this is 31. So how many line segments will be required when there are 100 fours? So the value of n here is 100. So 3 into 100 plus 1. So 3 into 100 plus 1. So this is 301. Now, how many line segments are required when there are 5 eighths? This is the algebraic expression for when there is n eighths, then the number of line segments required is 5n plus 2. So, value of n here is given to as 5. When there are 5 eighths, then how many line segments will be required? 5 into 5 plus 2. So, this is 5 into 5 plus 2. That is equals to 27. When there are 10 eighths, then how many line segments will be required? The value of n here is 10. So 5 into 10 plus 2. So 5 into 10 plus 2, that is equals to 52. So 52 line segments will be required to form 10 eighths. When there are 100 eighths, then the number of line segments required is 5 into 100 plus 2. So this is 5 into 100 plus 2. So this is 502.